making inserts for my goggles.
Oh, really?
Yeah. Okay, I'm launching. You might want to back up a couple steps. Okay, land. I'll get out of the way. Oh shit. Slow down, man. Holy crap.
Yeah, I guess I can maybe get a little lower on your base there or something.
Hi, this is AC and welcome. I'm sorry, I just cracked myself up. Welcome to another poorly planned live stream, and this one totally off topic. Nothing to do with RC planes really, or anything that I know anything about, which really I don't much about RC planes either. But what we're going to be doing today is see if we can basically see if these two little prototypes and look at, I'm going to document the prototypes basically. This is just for my own usage here. What is that? Number 11. There we go. These two little things are these two little perf, or whatever they're called, proto boards. Each have a Arduino Nano, and they each have one of these HopeRF modules, and actually this is the Adafruit breakout board version of the HopeRF module. So that's the HopeRF module in the middle there. Here too. There you can see it. That's the HopeRF module, and this whole board that it's sitting on is the Adafruit breakout board. And so we have two radios. And the idea is that, and this is just so screwy, but I'm going to build a little rocket. And the idea is that the rocket will have this little IMU in it, and this little radio, and a little power source of a battery, a LiPo, with a power regulator. I haven't gotten that far yet. This will all be not like this, of course, because it's going to go in a little rocket, but soldered together in a little package as small as I can get it, possibly. But right now, I'm just trying to see if I can get this radio to send the telemetry from this accelerometer to this radio, which would be the ground station. And right now, all it's going to do is spit out the accelerometer data from this radio onto the serial monitor hooked up to this Arduino. And also, it says that the stream is failing. Not enough video to maintain smooth streaming. So, yeah, I'm getting a recording of this anyway on my computer. The other thing we're going to do, assuming all this will work, is to then verify, because I did this in the process of trying to make all this work, and I still don't really know if it works, so bear with me here, because I've just altered a bunch of code. But we're also going to verify that we're getting transmissions on the 915 megahertz band via the software-defined radio and SDR Sharp software. So there's a few little things we're going to do really easily. So what I thought we would do is first what I need to do, and this is for my own purposes, but I couldn't find anywhere that documented exactly how to. I'm a simpleton. I don't know what I'm doing. So I follow other people's directions. And all the code is just all the code from example code, Arduino example code, just mixed together into separate files for the receiving unit and the unit that goes into the rocket. And I'll get the rocket parts out to show you. It's also going to have a little FPV. That's what relates it to RC, is the rocket is going to have a Caddx Ant camera and a little VTX, and it has a little 3D printed part to have the camera pointing down out the side of the rocket. Enough about that. We'll talk about that later if we have time. So, I hope the mic is working. I should have checked. I'm such a terrible live streamer. So anyway, these two radios, what we're going to do is we're going to look at the code for each one of the radios. Oh, first we're going to document how we hooked this up because I haven't really written it down. And I think I finally got it hooked up right. So we're going to document how I have it hooked up. We will, should I zoom in a little? We'll document how I have it hooked up. And then we will upload the code to each one because there's a different version of the code. There's a code for the sender and a code for the receiver radio. And then, so we'll do the code for the sender first, and then we'll do the code for the receiver second, and then we'll leave that plugged into the computer and look at the serial monitor to see if we're indeed getting packets of accelerometer data from the sender unit. Does that make sense? And then we'll plug in the SDR and see if we're getting the unit to see if we can see the radio waves in the waterfall, to see if we can see the packets, see what it looks like in SDR sharp. And again, I don't know what I'm doing. This is not, like, I couldn't find any beginner information. This is like a really, this RF M, it's M for module, I think, for our Adafruit, but it's the HopeRF RF69HCW. And they're still for sale, so it's not like a excuse me. It's not like an obsolete product. The Adafruit module is still for sale. Now, let me just have a caveat here. The MSA301 accelerometer that I'm using here is a discontinued product, but just like within the last week or two, it says excellent connection, so my stream is back. It looks like it's working again. To 0 viewers out there, thank you everybody, peace out. I'm such a jerk. Anyway, what was I going to say? So Adafruit just released like a breakout board of the same form factor, this Stemma QT form factor, and of this accelerometer, a newer version called the MSA301. So it went from 301 to 311. So it's exactly the same size as this, and I'm sure it works. They have a new library for it, I think, or maybe the old library still works. I'm not sure. But the Stemma QT form factor, I'm not exactly following it. Although I buy stuff from Adafruit a lot, I don't really pay attention to their anyway, it has like little connectors on each end, so it's like I think this is I2C. So maybe all the Stemma QT stuff is I2C sensors or whatever, and then you can just hook them together without soldering. Great, whatever. So anyway, I have soldered pins onto this particular one, and I have soldered pins onto both the modules, so I can put them in my breadboard. That's what this is called, a breadboard. So you can tell I don't even know what this stuff is, even though I have a lot of electronic gizmos, and I do a lot of really beginner level stuff like this. Like I've programmed NeoPixels. I've programmed NeoPixels and servos and things for various purposes. But anyway, so what did I say we would do? We would go through the wiring. So this is like kind of junior league here, but what I have is this printout, and really what I need is another printout. So hold on, let's switch over to the computer laptop. There we go. And here, this is the code I'm working on, but let's just get The browser, okay. And I thought I had like a picture. No, not that one. Here we go. This one. No, redirect. I just want the picture. View image. Is there view image? Save image as. Is this going to be good? D-U-I-N-O, Nano 2. This one is a little bit more detailed than the first one. And then, what about this one? What is that? Oh, okay, Google Lens. Thanks. Nope. I want this one. Back. Nope. Back. Okay. None of those do what I want. So save image as. I assume that it's the whole image in there being just... Oh, am I saving this to downloads airfoils? Great. Okay, well, we'll get there. So sorry, folks. I'm an idiot right now. You're seeing it firsthand. Okay, so... Oh, that's the one. I don't want that one. This one. Open with paint and print. Just print. How about that? Print. And we'll print it onto that. Print. No, I don't. Oh, that's. Both of these are wrong. BLE printout. No. This one. This is the one I want. I'm printing the wrong one. Yep. Back into airfoils. Here, back into airfoils we go. And there. No, 10:20 p.m. There we go. Okay, this is the one we want to print. Okay, print to there. Here, can we shrink it down a little bit? Here. Full page. 5x7. There, that makes it a little bit easier for me to write stuff on the side. Let's print that. 2 copies. Okay, just in case I want more. Okay, we'll start with this one. Oh, and I didn't have it. Jeez. I must have pressed a button or so. Oh no, never mind, I fooled myself. Okay, so back to this here. And I think I need more light on it, maybe. Not very much. It's pretty dark. Pretty dark. Okay. So let's document the, let's see what we got out of the printer too. Okay, is that a Nano? That's kind of like a Nano, this one, but that's got too much. That we'll refer to later. Here. These are the ones we want. Okay. So, this one will be the receiving unit, the ground station. RX unit. GROUN station. I can write. Okay. So we're going to go. This goes to. We're just going to do one at a time and we'll work our way across. So here, let's zoom in. Oh, too close, too far. There we go. That's about as good as we're going to get it. And then we're going to change glasses. I'm going to be up late tonight because I was deathly sick all day today and in bed, so it's just like hard to go back to bed now. So I decided to do this instead tonight. Figure this out. Okay, so here we go. This is the RX unit, and we're going to do the RF69 pinout connection. So, RST goes to ground for now. That's one thing that I didn't know. So, this rightmost pin is the RST pin, reset pin, and we're just putting that to ground. The next pin, also, by the way, I figured this out by looking at something that totally didn't match, and that was this one. On the Adafruit page for this thing, they show it wiring up to a Metro, which is basically an Arduino Uno, and so I just basically transfigured the pins from whatever was on the Uno to what's on the Nano. Very simple, okay? So that's how I sorted out the wiring. Because there's no like somebody that's on the internet that says, okay, you've got an Arduino Nano and here's how you hook it up to this particular Adafruit module. Because that's what I need, a simpleton explanation like that to save myself from many moments of time figuring it out. Okay, so the next pin over from the right, I'm going from right to left, so we started at reset. Then the next one is the CS pin. And the CS pin is part of what we're doing SPI. So we're doing RF69, we're doing an SPI connection. I'm going to write that down here. SPI. Okay, so this is how you do SPI to a Nano, basically. So any SPI would work the same way, I think. Any SPI devices. So this CS goes to what's called the SS pin. And the SS pin isn't really marked on here. This is where I got thrown off. SS is slave select. That stands for slave select. And CS is, I think, cable select, or I don't know what it stands for. Or I don't know. Connection, something select. So, but there's no SS pin. See, oh, right there. There is an SS pin. See, but I'm blind, so I didn't see it. That's exactly the same thing that happened to me when I was trying to figure this out. So CS goes to D10, or which is pin 13. So we're going cable select, the second pin, that's this yellow cable, going to D10, what's often marked D10, the third pin down. There's so many pin numbering systems on each device, so whichever one you want to choose it. But I'm using the one that's silk screened on here, which is D10. So we're going D10 to SS. So this goes to reset to ground, CS to D10. Write that there. Then the next one over is MOSI, and MOSI goes to the MOSI pin, conveniently right next to the SS pin. How convenient. So D10, so MOSI goes to D11. D11. Okay. Then we have MISO, and that's this one here, D12. MISO is the next pin for SPI. So we're going from MISO to D12. Again, it's not going to be silkscreen on your device, your little Nano clone from China. You're not going to have that on there, D12 MISO, or maybe some of them do, but I don't know where they'd have room. It's a really small little thing. So basically, these 3 pins are the SPI pins, plus then the next pin after that. So we've done reset, CS, MOSI, and MISO, MOSI, and MISO. Then we have SCK, or the system clock, or sync clock, or whatever that stands for. And sync clock is up here, D13. So that is D13, and that should be D13 is over on this side here. This is D13. So we have SCK2 D13. Okay, and then those are all the connections for the SPI bus on this. Now there's a few more cables connected. Oh, yes, no they're not. This purple wire here. The next one over from SCK is this one labeled GO, and I think that's GPIO0. So what you have here is the module itself has GPIO ports, and the GPIO0 is right next to SCK to the left of it. And then the other GPIO ports are on the other side. And I wasn't going to be using those, and I did not solder those because one of these is going to go into a little rocket. So I didn't want to have a bunch of pins on it. What I should do is get an Arduino Mini 3.3 volt and get this by itself, the HopeRF module, to go in a rocket if I was really smart, but I'm not that smart. The other thing is that you should know is this is 5 volt tolerant. This is not, this module is not, but the breakout board is, because it has, that's the way Adafruit designed it, and it has a voltage regulator and a level shifter and all kinds of stuff there. So the breakout board is well designed to be used with 5 volt Arduino Nanos like this one here. So I hope I've covered all this. This is all stuff that I was trying to figure out. I took time to figure out, so, and I'm making it take way longer than it needs to, and so there you go. But like I said, I'm just telling myself this to document this for myself. So the GPIO pin, back to the order here. GPIO 0 goes to Arduino pin D2, and the reason that is D2 is also interrupt 0. Interrupt 0. So we want GPIO 0, GPIO 0, which is just G0 labeled, to go to D2. So those are the pin layouts. That is the pin out from here to here. So if you wanted me to put the parentheses, we would go, let's just say like 4 here. We'll go to, oh, there's one more thing. We haven't powered this thing. So like I said, it's 5 volt tolerant. So I'm just in this case, I'm just powering it from the breadboard's 5 volt rail. So that is these 2 pins here on the very end. So we went reset from the right to the left. We went reset to ground. We're pulling it down to ground. What you're supposed to do, I think, with the reset, let me go back to the reset pin. Because I'm a newbie, I don't know what the frick I'm doing, right? And the different things where I was trying to look at the library code to see what you did with the what you did with the reset, and it seems like it kind of got glossed over. Even Lady Ada, was watching her actually solder the prototypes for this on a live stream, and I just did a bunch of stuff to try to figure out, because I don't know what you do. What is the purpose of the reset pin? I didn't read the whole data sheet because that's too beyond my, it's over my head right now. So for this little project. So, but you can pull it down to ground because that's what you would do with the reset pin, right? You would either pull it high or pull it low. So I just thought pulling it high is how you reset things, I think, usually. So I don't want it reset. I just want it to run. So we pull it down to ground. That's what we're doing. So what you probably do with this is control it by pulling it, having it go to a digital pin, unused digital pin, and in the setup code, before you initialize the device with the library code, you would tell the digital, you would write low to digital pin, whatever digital pin you put the reset pin on. Right? Correct? I think that's what you would do. I'm not that smart yet, ever. This is like I said, I learned from other people. I'm not a teacher, I'm a learner. Okay, so back to where we were. We're going all the way wiring again to review because I did a bunch of gibbering in the middle of it. From right to left, backwards, or frontwards if you're from the Aramaic side of the world. Okay, so reset goes to ground. Like I just said, you should probably do it to a digital pin and pull the digital pin down. That's what you should probably do with it. I'm pulling it down to ground. That's the way it's happening. Cable select, or CS, I don't know what that stands for. CS is going to the SS pin, which is also D10. The SPI library takes care of these pin outs here. These pins. These SPI pins, MISO, MOSI, SS, and SCK. Those are the SPI connections, plus the interrupt, plus the reset, but let's just leave those out. This is like all the data and clock connections, and they are labeled thusly. That's what I'm trying to say. So, starting again. Let's just start again and get through this. Reset's pulled to ground. CS goes to SS, slave select. MOSI goes to MOSI, D11. Slave select D10. MISO goes to D12, MISO pin. SCK goes to D13. D13 is the SCK pin. Then next is the GPIO 0, which is labeled G0 on these Adafruit modules, goes to pin D2 over here, D2. Then we have the, I said SCK goes to D13, right? SCK to D13, MISO to D12, MOSI to D11, CS to D10, reset to ground. GPIO to D2. We've got all those covered. Then in addition to that, we are pulling the, we are powering the unit from 5 volts. So we have it connected to the 5-volt rail on the little proto board here. So here's the ground. Oh, nothing is connected to the enable pin. EN. There's nothing connected to that. I don't know anything about that. Nothing is connected to the other GPIO pins on the Adafruit radio module. So, again, on this unit, the RX unit, that's done. We're going to TX unit. It's going to be the same exact thing. So we'll just write all that down. The RF69 pin connections. F69 pin, and we've got reset to ground, and we have CS to D10, and we have MOSI to D11. And we have MISO to D12. And we have SCK to D13. And we have G0 to D2. So those are all exactly the same. If we look here, reset is getting pulled to ground, and it's on the ground on the power unit is what I'm using for this one for some reason. CS, the little yellow wire, is going to pin D10. So this is D10, 11, and 12 on here. 10, 11, and 12. So the next one is the blue wire. That's the MISO wire. That's going to the MISO port, D11, and then the brown wire, the MOSI, or the blue is the MOSI, the brown wire is the MISO. Let's make sure we have that right. This brown wire is going to D12. D12 is going down to this. Follow it down. I used two wires the same color right next to each other. Really stupid. It's going to MISO. And the SCK is the next one. And the SCK is going to this pin, D13. That's what that little jumper's doing. SCK D13. And then we have G0. G0 is this yellow wire, and G0 is going to D2 on the top. So just like I have documented. Then these two jumpers are just to power the Arduino from the power rail. Then we also, on this unit, have additional connections. We have on the TX unit, we have the MSA301 pin connections. We should document those too. So we have 4 pins going. This is I2C device. And, yeah, what was I going to say? I2C, voltage in, and I've got voltage in, ground, SCL, and SDA. And SCL and SDA, as you can see here, usually go to D18 and D19. And so, let's see where we have those going on this device. We have those going to those A4 and A5. That's how they're labeled on the Nano that I have, A4 and A5. So what we have is SDA. SDA is the green wire, and the green wire is going to A4, and A4 is SDA. So we have SDA to A4, and then we have SCL to, and that should be going to A5, and that is the blue wire, and the blue wire is indeed going to A5. So then we have only the power in the ground, and so then we have the GND to GND, and we have 5 volts. This is a 5-volt tolerant device, I hope. So 5 volts to 5 volts. Those are all the pin connections needed for this. So it looks a little bit more complicated. There's a 470 microfarad low ESR capacitor here. That's just because it was already stuck in the breadboard, so I'm leaving it there. Why not? Can't hurt. On the power rail. That's it. So the next step, man, if I wasted a lot of time, how much? 42 minutes. This is like 5 minutes of exclamation. This is 5 minutes. What did I do? I described the units. Okay, so now what we're going to do is do the code. Let's do this. Holy smokes. Okay, so let's switch over to the computer. And so let's do the sending code first. So this is taken again from the, all this is just demo code from the demo, library demos. Every Arduino comes with libraries. Every Arduino library comes with examples. Excuse me. So I started off with the accelerometer demo code from this Adafruit MSA301 library. If you buy something microcontroller related, usually there's Adafruit has developed libraries for various platforms and like CircuitPython and all that, Arduino and all that stuff. So here you go. The MSA library also relies on the generalized Adafruit sensor library. We're also including the SPI library, and that's to talk to the radio. So basically, again, this is not the exact accelerometer demo file because I use that as a template to make my file. I don't know how to write code on my own. I'm going to use the example file, and so do many other people. That's why the example files are included here. So I basically mushed up the example file from the radio, the RF, let me see here if I can say it, show it. So the RFM69, actually this library that I'm using is not an Adafruit library. It's the library from, so the library I'm using to run the radio is not, run the radio from the on the Adafruit breakout board is not the Adafruit library or the Adafruit's fork of the Radiohead library. I'm using the older low power lab RF69 library here. And the reason is because I couldn't get it to work. I had the wiring wrong, but I couldn't get the Adafruit libraries to work or the Radiohead libraries to work. So I tried these libraries. And then I figured out the wiring, and I was using these libraries. So I'm sticking with these for now because everything's working. So basically, let me start from scratch here then. So sorry, this is crazy. I'm taking so long to explain to myself what I'm doing. I'll hate myself for that later. So I'm meshing the two example files together. So I'm including the RFM69 here. I'm initializing both devices. This code here is just to define some constants that are in use by, this is for the radio stuff. And I'm also flashing an LED, why the hell. I'm going to add extra stuff to it because I like to, because that's the way I'm playing. Then another demo that I took this from was the struct, I should say that from the radio RF69 libraries, there were two demos, the struct send and struct receive. That's the library's example files that I'm using to, that I kind of meshed into here. So what I did was I took their example and made my own struct called payload. So I defined my payload type of variable, I guess you'd say, and then I'm initializing it in one called the data, and that is going to contain the 3 accelerometer values x, y, and z. Very simple, very, very simple. Again here, all example code. So we initialize the accelerometer. And then we get some information from the accelerometer, some of the parameters. Then this, again, I added this from the other example files from various places, but mostly, and then just set up a little if statement here to tell me if the radio initialized. And I'm sure not, I think we're going to hopefully get it initialized on this run. Okay, so here's what we're going to do. Oh, and then at the very end, so all we've done here is set up the radio. That's it. Then here we're in the loop section. And this is where all the work gets done, of course. And this is totally unnecessary, I think. But I'm spitting out the value, the raw values, the raw data out to the serial monitor. Then here we're getting the real, what I want is meters per second squared acceleration, right? Those are the values we want for fun, for graphing and things like that. So this is how you get that, again, from the example code here. And then adding in stuff to send it to the radio. So at first I was playing around with what they were doing, and I'm so bad at C++ and C that I couldn't even figure out how to make a proper CSV kind of line. That's what I was trying to do here. Didn't work. So tried it a couple different ways, just couldn't get it to work. So there you go. So what I ended up doing was changing the struct to just contain the data XYZ. So that's what we're doing. We're building the variable that we're going to send across the wire, across the air. And then here we're sending it, again, exactly from the example file. I don't exactly understand. I need to look up why this is formatted the way it is. It seems awful complicated. Why are we putting this in here? I don't know. What is the purpose of the asterisk? I don't know. This, I think it means a reference to this and not that. I don't know. And then this is the actual size. Each packet has to give a size of the packet that you're sending. There it is. That's the data packet. It says the size of the data packet. That's just a function of C++ there. So then we're blinking the LED with this blink function that we put at the very end of the file. So this is the end of the loop right here section. At the end we delay and then we'll read again. Okay, so we'll delay 1/10 of a second and we'll read again. So actually that's kind of too fast. Or too slow for the rocket, but let's just make sure it works, right? So the next thing we're going to do is we're going to verify and see if it actually compiles. And look at that, it compiled. So then the next thing we're going to do is we are going to plug it in to the computer. So this is the sending unit. The Excel demo file is for the sending unit. That would be this one here, the transmission unit. I should put in rocket, right? Rocket. It's the rocket. Okay. Looks like a rocket, doesn't it? So we're going to plug this in carefully so I don't break anything. It's all powered on. So then we are going to upload this. And as soon as we're done uploading, if it all works, oh, look at that, it's writing. Oh, right down at the bottom there, you can see writing, verifying. Thank you, it did it. So now we're going to open the serial monitor. Where is it? Serial monitor. Oh, look at that. There's data, sending data on the radio. So, we're getting data sent. Now, there's something very curious about this, you might notice. Not really to anybody who's a scientist. I am not a scientist. But if you look at the z values over here. Why are they 9? Why are we moving down 9? Why is there an acceleration upon us of 9 point something meters per second squared? Why, flat earthers? It's frickin' gravity, you morons. God, flat earth people are morons. Now, isn't it 9.2 meters per second? Maybe it's off because I'm not at sea level. I'm 1,100 feet above sea level. Could that be it? Well, if I actually had an audience of people, somebody might tell me. But anyway, okay. So if I move this around like this, you can see the values going everywhere, right? So we got some code that's working. Now what we're going to do is unplug this. We're going to close the serial monitor. We're going to unplug from the computer. So we've turned the rocket ship off. Excuse my laughing. And over here, do I have a, can we get a camera angle? No. Sorry, I gotta fix something here. There we go. Powell isn't the one. Powell Spakowski is not the one who thought of doing live streams to make content to edit later, although I never edit it later. Okay. I was doing that a while back, but I didn't edit it. No, never mind. He's way far ahead of me. Okay, so this here's sending unit. Now we're going to hook it up to this guy over here. We're going to turn this on. It's my bench power supply. And we're going to plug this 12 volts. 12 volts goes in. These little things here. If you're wondering what this is, it's a little breadboard friendly power supply. And what you do is you put 12 volts into it. Has a little power switch, an LED, capacitor, and a couple of voltage regulators there. And it has a 3.3 volt and a 5 volt, and you can turn each side either onto 3.3 or 5 volts. Plus there's permanent 3.3 or 5 volts on these pins here. There's a 5 volt USB port. I don't know how many amps it puts out, but anyway, so you just plug 12 volts in there. It's a 5.5 by 2.5 barrel connector, and you got a 3.3 volt rail and a 5 volt rail on your breadboard, if you want, or both 3.3 volts. You set each rail with these jumpers here. So that's what that is. And these things are super cheap from like AliExpress or Banggood, lots of places. Okay. So what we're going to do, God, I take so long. What we're going to do is we're going to power this thing up. I'm going to make sure it's off. Okay, we're going to power it on. And then we're going to go over to here. And we're going to see if it's actually transmitting. How are we going to actually see if it's transmitting, you ask? Well, we're going to go to, is it that one? Yeah. We're going to do the SDR sharp. So what we're going to do is we're going to plug in this doohickey here. This is our cheap ass serial, our SDR, serial defined radio, software defined radio device. Okay? Google it. You know, everybody knows about these that was interested to software defined radio. There's all kinds of little kits on Amazon and Banggood, and everywhere else. SDR is what you want to look up. So go to STR or RTL-STRSDR.com. I don't know. Anyway, SDR sharp. Let's go here. Let's turn this on. Oh, it's working. Oh, so let's... Ooh. I don't think we have audio from this. I wonder if I could get audio from this. Here, I know how to get audio from this. Just put this microphone over here. Now I won't reach because I have a cable tied in. Well, anyway, what you can see there is the data going across, because let's turn it off. So it is actually sending. So there's going to be all those horizontal bands going there are going to disappear now. They're going to go down the waterfall and go away. Because that radio's turned off. The rocket's turned off. Let's go back. Let's turn it back on. Now it's booted up. Here we go. That is the data getting sent across there. So now, if we're lucky, we're going to get data on our... We'll get data on our receiving unit. So we're going to stop the SDR sharp. So now let's go back to Arduino. Now let's look at our receive code. Our receive code is simpler because we're not going to, we're not collecting any data. We're just receiving it and spitting it out onto the serial monitor. That is the only purpose of this. So it's our ground station just initializes the libraries that we need, the RF69 radio library and the SPI library. Should I have done that in the opposite order? We'll find out. This is kind of like the gateway, so it's node ID 1. We call it node ID 1, and we gave it the same network ID as the other code. If we look at the other code just really quick and go to the top, we have a network ID of 100. So that remains the same for all these devices together on your network, right? But we gave this a high node ID just to get it out of the way of far away from 1. And the gateway, the one we're sending it to, is number 1. Radio ID number 1, which is this one right here, node ID 1, right? Very simple. Oh, and we also use the same encrypt key. Let's double check that. Sample encrypt key, sample encrypt key. This key needs to be 16 characters long, not less, not more. Explains that in detail right there. And I think that's another problem I had but that did not stop the radio from initializing, so that wasn't my problem. Okay, so we're given a pin definition for the LED, serial baud. I don't even think I use this. I copied this one from the example file and didn't end up using it actually. Or maybe, oh yeah, there it is. So we're doing the same struct definition. We're creating a type of struct, and we're giving it a name of payload, and we're giving it these exact what are they called? It's like values in an array. A struct is like an array, right? So these nodes in your array are defined, and they are exactly the same. Critical here, they are exactly the same as this struct that you define here. Doesn't matter what the name is on each side, but the actual values and these names, they must be the same. The names and the types must be the same. The number of them, the name of them, and the type of them must be the same between these two pieces of code. So we're back to receive. So we've done that. Now, back down, going a little further, we're just, okay, here's some crap we don't need right here. This stuff, we don't need that. We don't need the promiscuous knit mode. We're not playing with that, but that's all from the example code. And this I added just to spit out stuff to the serial monitor so I can see if it's freaking working or not. This is from the old way that I tried to do it. Oh, no, never mind. This is just to make a, they're just telling us which frequency has been selected by our software definition. Again, that's up here. RF69, I glossed over that. In fact, I haven't even talked about that. You must set this frequency correctly, of course, for your particular radio and your particular region. These are 915 megahertz radios, version of the radios. Okay. Also, I also glossed, and I probably screwed this up, but you have to make an antenna. You have to make an antenna, and the antenna is just this case is a piece of solid wire, and you have to decide how long it is. In this case, I believe it is 73.5 millimeters. I tried to make it, or something like that. You can see how long it is. It's longer than my pinky a little bit. Now, I looked that up on the internet, and I think I got it wrong. I think that's half as long as it should be. So it's like a quarter wave antenna, probably, for 915 megahertz. But we'll see if it works. At least we'll let it radiate energy out into the air as opposed to breaking the unit, right? It'll radiate energy out into the air. So, all this part is from the example file, and I'm not using it. It's supposed to collect your keystrokes from the serial monitor and then send commands to the radio to change its thing. And I left it in there because we could use it if we wanted to, but we're not doing that. This is the part I care about. When there is a receive event, the radio has, at the end of the receive event, does a receive done event, and you can check for that with this. And so as you're going through the loop, you're checking to see if it's received some data. And what we're doing here is, because we're sending this information, this packet, the protocol sends an ID. That is the ID we should get. It sends an ID, it sends an RSSI value, so we get other information besides the data that we're actually sending. We get some, what you would call metadata, I guess. Very simple, but effective for my simple rocket telemetry system, right? So again, here's the part that I kind of cobbled together from examples, and I don't even know why the syntax is the way it is. So, like this part here, why is the syntax like this? I know I don't have any viewers, nobody's watching this, so it doesn't matter, but why is this like this? What is that syntax there? I don't know. I'm going to have to look it up. But here we're getting the data packet. And then the data packet is that structure, that struct that we created up above and in the other, in the sending unit. So the struct is sending us the data node ID and the data timestamp and the data Excel X and Excel Y and Excel Z. And again, those values, again, simpleton, I'm a simpleton, but this is where it comes from, right here, right here, right here. These are the values inside the array, the data structure. Here again is some more code from the example that I just left in. We're not actually using it, but it doesn't hurt. I can maybe use it later if I get more complex. And again, I'm using the blink, same blink code as in the other one. So, wow, that took a long time for me to just go through that, didn't it? No wonder I don't do this for like a job on the internet, right? Because I don't know what the hell I'm doing. Okay, so there we verified and we have compiled. So now what we're going to do, now what we're going to do, oh, now what we're going to do, now what we're going to do is unplug the SDR because the USB ports are so close together and this SDR has a big fat thing and I can't get to the other USB port. We will plug in the Arduino for the receiving unit and we're going to upload the code. Let's just look at the serial monitor and see what's going on. Nothing. Oh. Yeah, we got to upload the code. Okay. So let's switch to this here so I can show you what's going on. I think that we're getting somewhere. So I'm getting packets. RSSI minus 26. What the problem is that I don't have the current version of the code up. So what we're going to do is we're going to close this. We're going to upload the code because the code that's here has the correct structure definition. So now we're going to go back to the serial monitor. Oh, please. Oh my God, there it is. There it is, folks. It's working. Excellent. We've done everything. It only took me 1 hour and 9 minutes. Well, that's not too bad, actually. We've done everything that we wanted to set out. Our code is working. So let's look at it a little closer. Let's look at what we're doing here. So let me go back to this one. There we go. Let's, over here, I should say, how many times can I switch? Over here I have the sending unit and the accelerometer is connected to the sending unit. So if I switch over while I'm moving this to this, we should see the values going all over the place. And then if I stop, let's get a steady state. And here you see it's pretty steady. It's moving. Oh, I don't have it. It knows exactly where it is. If I'm not perfectly level. Now, it does need a little bit of calibration, I think, but that's what we're going to do just based on what the launchpad values are. So the next step in this, I am so happy. My little simple telemetry system is working. So that's how it works, folks. That's how you use the the Adafruit RFM, the Adafruit RFM69HCW modules. It's very simple. I like it. It's sending data across. So the next part, what I should do is describe what it's going in. I said a rocket. There's actually a rocket. It's a little Estes, few parts of the rocket. So what I've done here is I'm going to have a FPV unit in there, and let me just show you how that's going to work. So this part, so here's like a rocket tube, right, for a crappy rocket, Estes little rocket, and then this little sleeve. So actually, I don't know. I think that the shorter part's going to go on the bottom and the longer part's going to go on the top. Don't know anything about rocket dynamics, folks. That's my daughter's job. I hope she'll tell me what I'm doing wrong, maybe. But here's our rocket tube. And then inside, in the middle somewhere, in part of the rocket tube, is this little electronics bay section, right? And the purpose of that is to hold. So here it is. This little part, this is like the bottom bulkhead that protects the electronics from the fire of the parachute pyro, right? So, okay, so we put this, that goes in there. And the electronics being the camera. So the camera is a Caddx ant. And the Caddx ant, it's not exactly easy to get in there, but it does fit in there. I've test fitted in there. And the little lens will just stick out the little hole there. It fits right in there. I don't want to stick it in there because it's a nice fit. It's a snug fit, but it does go in and it does come out. So the Caddx ant will be connected to a crappy little VTX. This is just a little rocket after all, going to fly for 2 seconds, right? The motor, the C65 motor that it'll probably carry, which I hope it has enough newtons of impulse to send it up in the air. So we got a little VTX. The little VTX with this little VTX antenna is going to go here. Then we have to figure out, this isn't so perfectly well thought out, but then the sending unit, all this stuff. So I don't know if I'm going to, now I've got to think about how I want to put, so the Nano, oh, and then it's going to be powered by 2 batteries. So basically the further components that I need, I got these 2 little tiny whoop batteries, and they're going to be wired in series to make like 6 volts or something. And then that's going to go into a little tiny, one of those little tiny Maytech voltage regulators, which I do not have in my project box yet, but I will get it in here. So there is a rocket. There is an actual rocket. It came from 2 different rockets. One was one of these free falls, and I actually have another rocket of the same size coming, so that there's one for Leah too. If I can get her to, I'm going to try to get her to bring her rocket too that we've already built. I got a whole box of motors. So let's see if our telemetry system is still working, and then we'll close out the stream. Telemetry system. That's really hilarious that I'm calling it a telemetry system. But it is sending us data. And what I need to do now, oh, let me explain what the next step is. The next step is to get, I want to get one of the, I'm going to order one of these from Adafruit. Let's, here, Adafruit memory flash. Let's go to the store, shop, flash memory. Okay, oh, there it was. This one right here. So now I'm going to add this SPI flash card. So I'm going to get 2 of these. Order now to ship today. Today, really? No way. I'm going to get 2 of these. And I'm going to put one on each end. And the reason is that I want to be able to spit out the data, and I want to be able to compare the data to see how many packets were lost. I don't know. It's just like, oh, I'm not even showing the thing. Here, there we go. So I'm going to get one of these. Let's go back to this. Back. There. It's a 512 megabyte. So way overkill. But look, it's a little SPI SD card, and it's not an SD card, so it's not going to come out dislodged by the rocket or whatever craft I end up putting these in eventually in the long run. So that's a kind of a cool little thing, I think. I mean, it's way expensive for how much memory you're getting, but for the purpose. So I should be able to connect this to the SPI bus that I'm creating inside this rocket. And so that's the next component that I'm going to add. I'm going to add that, and I want to add on the receiving station so that when you move the accelerometer, we're going to have neopixels on the receiving station for the X, Y, and Z to X, Y, and Z, the colors. Why not? Okay, so that's all I've got, really. That was an hour and 18 minutes of really boring stuff. And somebody just started watching, so I'm sorry. Oh, there's a chat. Who do we got? Bark Tech, Facts Tech. Can't read fast. Hi, people. I can't believe you're actually watching this, but I got to the end, so you'll have to rewind. But it's working. My little stupid newbie test is working. And what I'm thinking is I could put these on RC planes as a secondary. I'd have to get a different radio frequency because I don't think this is going to work well with R9 on the same band. So probably not a good idea to do 915 megahertz. But this is could be the basis for some kind of a backup telemetry if you add a GPS or something to it, like on 433 megahertz. I'm going to look into that. Kind of like INAV radar works on. Yeah, never mind. We'll just go on to that later. Okay, so just wanted to say thanks for watching. Enjoyed. Say thanks, Timeless. Didn't show that you were watching at all, but I'm glad you enjoyed it. Hope it was. I hope I showed. I don't know anything about this stuff, but I'm learning a little bit, and it all works. So thanks for watching. Y'all have a good one. I'll be back with some real RC plane content because the next thing that I'm working on, it's all ready to go. I've got it organized. I worked on that a little bit after I started to feel better this evening. And then I decided to do this, but is the FPV combat with the flight test aero wide pod version wings for me and my two friends that we fly together. We'll do that soon. Peace out. Thanks for watching. And have a nice Saturday. No, it's